We are Group 1 from sections FN1
and FJ1. Minitab?
No problem. We are here to help you.
Minitab is a software product that helps you to analyze the data. It provides a simple, effective way to input the statistical data, manipulate that data, identify trends and patterns, and then extrapolates answers to the current issues. This is most widely used software for the business of all sizes, small, medium, and large. Once you click the Minitab application, it will open two windows, the session window and the worksheet window. The session window is the one that will display the output, and the worksheet window is where you input your data. And as you can see, Minitab have a lot of tools that you can use. It's located up here. For this video, we'll specifically use the Stat tool and the Graph tool for solving ANOVA, a normal distribution. Stat menu, it contains basic statistics, regression, ANOVA, and so on. And the Graph tool is what we're going to use to make graphs of different types, like scatter plot, histogram, etc.
Hey guys, I will be showing you how to execute ANOVA exercises here in Minitab. So we have here a sample ANOVA exercise. An engineer wants to compare the hardness of 4 blends of paint. 6 samples of each paint blend were applied to a piece of metal. The pieces of metal were cured. Then each sample was measured for hardness. In order to test for the equality of means and to assess the differences between pairs of means, the analyst uses one-way ANOVA with multiple comparisons. In doing this task, we need data as our input. So we'll open this paint hardness file. This is where we're gonna get our data. Then we will open this one-way ANOVA dialog box and then select statistics. Since it is an ANOVA exercise, therefore we will choose ANOVA right here and then click one-way ANOVA. Afterwards, we're gonna select these responses are in one column for all factor levels. And then in response, we will enter hardness data. While in factor, we'll enter paint data. After doing that, we will go to the comparisons tab, then select Chuki. This is also the family rate. So then after that, click OK. And then you have it. It's done. You can now interpret the results.
So we now have here the two graphs, the interval plot of hardness versus paint, and a 2-key simultaneous 95% CLS. Also, we have the results written in the session window. As you can see, the session windows display the null and alternative hypothesis and the significance level. And then we have here the analysis of variance, which we can use to interpret the data. Here, the p-value of the hardness of the paint is 0.004, which is way lesser than the significance level. We reject the null hypothesis, and the other way around would be the rejection of the alternative hypothesis. Therefore, we can say that the null hypothesis should be rejected. Accepting the alternative hypothesis in that way, we can say that not all means are equal and the hardness of each paint blends is significantly different from one another. Next, the two key simultaneous 95% CLS. This graph shows the differences of means for hardness of each blend and to see if there is a significant difference or there is none with the corresponding means. As you can see here, the note says, if an interval does not contain 0, the corresponding means are significantly different. For that reason, we can say that the means of each pair of blends are significantly different from each other since these blue dots didn't pass 0.
Lastly, we have here the interval plot of hardness versus paint. This just shows the differences of hardness between paints. And as the graph shows, there is exactly differences between the paint blends. So, that's all for the ANOVA exercise. Next, we are going to have a sample exercise for normal distribution. The normal distribution. Let X represent the duration of an 8-week-old baby's smile, where X is normally distributed with mean, which is 9.1 seconds, and standard deviation of 2.2 seconds. What is the probability that a randomly chosen 8-week-old baby smiles between 6 and 12 seconds? Compute the answer by hand and check it with Minitab using the process described below. Graph and then click the probability distribution plot. Then choose View Probability, then click OK. From distribution, you have to choose normal. In mean, you have to type 9.1. And then in standard deviation, type 2.2. Click the Shaded Area tab. Under Define Shaded Area by, you have to choose X value. Then click Middle, since we want the proportion of 8-week-old babies with a smile duration between two values. In X value 1, type 6. In X value 2, type 12. Click OK.
We have mu equals 9.1, standard deviation of 2.2, and then a range of 6 to 12 seconds. For us to solve the density, we can use the formula f of x is equals to 1 over b minus a, where a is less than or equal to x and x is less than or equal to b. b is equals to 12 and a is equals to 6. Then substitution, we could get the density of f of x is equals to 0.17. For the probability of 6 less than x less than 12, we could write it in another form of the probability of x less than 12 minus the probability of x less than 6. And then before we could look for the value of the probability in the z-table, we should first do the standardization. Using the formula z is equals to x minus mu over standard deviation. For x is equals to 12, we have z is equals to 1.32, and for x is equals to 6, we have z minus is equals to negative 1.41. And then if you look on the table, we have the probability of z less than 1.32 equal to 0.9066, and the probability of z less than negative 1.41 is equal to 0.0793. Then subtract, we could get the probability of 6 less than x less than 12 is equal to 0.8273. If we look to the graph that the Minitab showed us, we could estimate that the density that we got is the same as the density in the graph, which is 0.17. And then solving by hand, our probability is 0.8273, which is near to 0.8269 that we got from Minitab. Therefore, we can say that Minitab is really a faster way of solving any statistic problems.
All the statistics
In the world
Cannot measure.
the brilliance
of compassion.